This is not a disaster alert. There is no emergency broadcast interrupting your screen, no flashing red lights, no countdown clock telling you how much time is left. Life is continuing exactly as it always does. People are driving to work, kids are scrolling on their phones, cities are humming, and yet, deep beneath your feet, something changed. Not loudly, not suddenly, not in a way you could feel. There was no shaking ground, no breaking sky, no moment where anyone stopped and said, "Did you feel that?" Because this wasn't the kind of event humans are trained to notice. This was quiet. So quiet that most people will never hear about it at all. Scientists didn't step in front of cameras, they didn't issue warnings, they didn't sound alarms, not because it wasn't important, but because they didn't expect it to happen. Far below Earth's surface, deeper than mines, deeper than drills, deeper than anything humans can reach, instruments began detecting signals that didn't match known patterns. Not an earthquake, not volcanic activity, not background noise, something else, a subtle shift, a change in behavior, a response. And that's the word that made scientists pause, response. Because responses don't happen randomly. Responses happen when a system senses stress. What makes this unsettling is not what happened, but why it may have happened. This wasn't triggered by war. It wasn't triggered by an asteroid. It wasn't triggered by a single catastrophic event. It appears to be linked to pressure, accumulation, long-term strain, the kind that builds quietly over time. Like a body that doesn't scream when it's sick, it just adjusts until one day you realize something isn't the same anymore. Earth didn't lash out, it didn't collapse, it didn't warn us, it adjusted. And that raises a question scientists are being very careful not to ask out loud yet. Because once you ask it, you can't unthink it. What happens when a planet, not a machine, not a myth, but a living system of balance, begins protecting itself? Not dramatically, not violently, but silently. Stay with me. It started with data. Not headlines, not breaking news, not panic. Just data. Numbers on screens, lines on graphs, signals quietly updating in research labs around the world. At first it didn't look important. Small shifts, tiny patterns, the kind of irregularities scientists are trained to question, but also trained not to overreact to. Because nature is noisy, instruments drift, sensors glitch, background activity fluctuates all the time, so most researchers did what they always do, they watched, but the numbers didn't return to normal. Seismic readings began showing movements that didn't match earthquakes, no sharp spikes, no sudden releases of energy. Instead, slow pressure changes, deep, persistent, almost controlled. Then came the heat data. Thermal movement deep underground started behaving in ways existing models couldn't fully explain. Heat wasn't rising where it should. It wasn't dispersing the way simulations predicted. In some regions it slowed. In others it subtly rerouted. Not chaos. Adjustment. At the same time, magnetic instruments began detecting irregular behavior. Nothing extreme. No dramatic pole shift. No global disturbance. Just slight deviations from long-established cycles. Patterns that didn't match the past. Individually, each of these signals could be dismissed. A coincidence, a calibration issue, a regional anomaly. But science doesn't look at signals in isolation, it looks for overlap, and that's when things became harder to ignore. Researchers in completely different parts of the world, working on different projects, studying different systems, began noticing something similar. The same kinds of anomalies, appearing around the same time, not connected on the surface, different continents, different environments, different conditions. But when the data was traced deeper, the connections emerged, the signals aligned far below Earth's surface, below fault lines, below crustal boundaries, below the depths where human activity directly reaches. That's when the conversations changed. Quietly, not in press conferences, but in emails, private meetings, carefully worded reports. One researcher described the feeling later. It wasn't alarming, it was unsettling. Here's what made scientists uneasy. This response did not follow a disaster. There was no massive volcanic eruption tearing open the ground. No asteroid striking the planet from space. No sudden global earthquake that forced immediate explanations. Nothing dramatic happened, and that's exactly the problem. In the past, Earth's major adjustments were tied to obvious triggers. A single event, a clear cause, Something you could point to and say, this is why the system changed. But this time there was no moment like that. Instead, the signals appeared during something far harder to define. Long-term stress. Not a spike, but a build-up. Pressure accumulating deep below the surface. Constant extraction of resources over decades. Thermal imbalance slowly spreading through land and sea. Subtle magnetic instability creeping outside expected ranges. Each factor on its own might seem manageable, but systems don't experience stress one piece at a time. They experience it all together. And when scientists laid the data side by side, a troubling pattern emerged. The changes did not align with a single event. They aligned with duration. How long stress had been applied, how consistently it had been maintained, how little recovery time the system was given. This is where the conversation shifted, because reacting to sudden shocks is expected. Any complex system does that, but reacting to patterns, that suggests sensitivity. It suggests the system is monitoring conditions over time, not just responding to emergencies. One researcher explained it this way. If you punch a wall once, nothing happens, but if you lean on it for years, eventually it adjusts. Or collapses. Earth appears to be responding to the lean, not violently, not urgently, but deliberately, and that idea unsettled people, because patterns are harder to ignore than accidents. An accident is temporary, a pattern is a signal. It means the conditions aren't passing, they're persistent. What makes this moment different is not the scale of change, it's the timing. These signals emerged while human activity continues uninterrupted. Cities expanding, energy demand rising, extraction accelerating, heat accumulating in places it wasn't designed to hold. Yet the planet did not wait for a breaking point. It adjusted early, quietly. That challenges a comforting assumption many people hold, that Earth only responds when things become catastrophic. But if Earth responds to accumulation, then damage doesn't need to be dramatic to be significant. It just needs to be continuous. This doesn't mean collapse is inevitable, it means thresholds exist, and crossing them slowly can be just as impactful as crossing them suddenly. The idea that Earth may react to patterns forces a harder reflection. Because patterns aren't accidents, patterns are behaviors, and behaviors can be changed if they're recognized in time. That's why this moment feels different. Not because the planet is in immediate danger, but because for the first time it appears to be responding to us not as a single event, but as an ongoing presence. There were no explosions, no shockwaves rippling across the planet, no cities shaking, no dramatic moment anyone could point to and say, this is when it started. And yet, something began to move, slowly, quietly, almost invisibly. Deep beneath the surface, heat began traveling in unfamiliar ways, not surging upward, not erupting outward, but shifting sideways, redirecting, taking paths that scientists did not expect it to take. At the same time, pressure zones began to change, not collapsing, not spiking, just rearranging. Areas that had carried stress for decades began to ease. Other regions, once calm, showed faint signs of activation. So subtle that only long-term monitoring could catch them. Certain fault lines, the ones scientists had been watching closely, went quiet, not inactive, but calm, unusually calm. Meanwhile, other faults showed slight movement. Not enough to cause earthquakes, not enough to raise alarms, just enough to suggest redistribution. This wasn't chaos. Chaos is unpredictable, violent, erratic. This looked measured, controlled, almost careful. Energy wasn't being released all at once. It was being spread out, shared, redirected to avoid overload in any one place, like water slowly diverted through multiple channels instead of bursting a dam. One scientist described what they were seeing in a private discussion. They didn't use dramatic language. They didn't speculate. They said, imagine a bridge adjusting its weight before cracking. That sentence never made headlines. It didn't trend online. It wasn't quoted in news articles, but it stopped the room. Because bridges don't adjust weight randomly. They do it because the load is changing, because the structure senses strain, and because waiting too long leads to failure. What made this comparison unsettling was its implication. If Earth was redistributing pressure, it wasn't reacting to an immediate threat. It was preparing, preventing, buying time. This kind of chain reaction doesn't demand attention. It doesn't scare people. It doesn't interrupt daily life, which is why it's easy to miss. But quiet changes often matter more than loud ones, because loud events are obvious. Quiet ones shape the future. What scientists were witnessing wasn't a single adjustment. It was a sequence. One shift triggering another, one area easing pressure while another absorbed it. A balance moving slowly across the planet. Not to erase stress, but to manage it. And that's what made this moment different. The planet wasn't waiting for collapse. It wasn't reacting after damage was done. It was responding early, silently, in ways that don't feel dramatic, until you realize how much has already changed without anyone noticing. That sentence about the bridge should have made headlines, because it wasn't about fear, it was about foresight, and whether the system beneath us is quietly adapting, while we remain distracted by the surface. So why isn't this everywhere? Why didn't it lead the news cycle? Why wasn't it debated on talk shows? Why didn't it flood social media feeds? Because uncertainty scares people, and this story is built entirely on uncertainty. This isn't a prediction, it's not a warning with a date attached. There is no countdown clock, no clear outcome to point to, it's a possibility. And possibilities are uncomfortable. They sit in the space between knowing and guessing, a place most people don't like to stay for very long. Admitting that Earth may have unknown self-regulating responses means admitting something even harder, that we don't fully control outcomes. Science is powerful, but it's also careful. It works best with repeatable experiments, clear causes, and measurable results. What's happening beneath the planet doesn't fit neatly into that framework. You can measure the signals, you can map the patterns, but you can't yet explain them with certainty. And science hates saying 3 words. We're not sure. Not because scientists are dishonest, but because uncertainty is often misunderstood. To the public, uncertainty can sound like ignorance. To media, it can sound like weakness. To policymakers, it can sound like risk. So instead of speculation, the language stays careful. Phrases like further study is required. Preliminary data suggests within expected variation. Nothing alarming, nothing definitive. The data stays in academic journals, in conference presentations, in internal discussions, places most people never see. And that's not a cover-up. It's caution, because once information leaves the scientific community, it takes on a life of its own. Nuance gets lost. Possibilities become predictions. Questions become conclusions. So scientists slow down. They double-check. They wait for more data. They avoid drawing lines they can't yet defend. That patience is a strength, but it has a side effect. Quiet discoveries stay quiet, especially when they don't fit into a simple headline. There's no easy way to say the planet might be adjusting to long-term stress in ways we don't fully understand. That doesn't spark clicks, it sparks confusion. So instead, the story stays underground, just like the signals themselves. Carefully observed, carefully documented, carefully discussed, but not announced. And yet the signals remain. They continue to appear, they continue to align, they continue to suggest something is changing, not urgently, not catastrophically, just enough to remind scientists that certainty is rare and that some of the most important shifts in our world happen quietly, long before anyone is ready to talk about them out loud. Let's be clear, this does not mean the world is ending. It does not mean a sudden catastrophe is waiting around the corner, and it does not mean Earth is angry. That kind of language belongs to fear, not science. What scientists are observing isn't rage or intention, it's response, and that distinction matters. Because panic comes from imagining dramatic endings, while understanding comes from recognizing quiet limits. What this means is far more subtle, and in some ways, more unsettling. It suggests that Earth may have thresholds, not bright red lines we can see, not alarms that go off when we cross them, but gradual boundaries, points where slow, continuous pressure becomes too much for balance to hold. And when those thresholds are crossed slowly enough, there's no warning. No permission asked, no announcement. The system simply adjusts. Not to punish, not to threaten, but to restore balance in whatever way it can. That's what makes this moment important. Because if Earth responds silently to long-term stress, then waiting for obvious signs means waiting too long. This isn't about fear, it's about awareness, understanding that some of the most powerful changes in nature don't arrive with noise. They arrive with quiet shifts that only make sense once they're already underway. Humans think in decades. We plan careers in years, cities in generations, technology in upgrade cycles. Even our idea of history rarely stretches beyond a few hundred years. Earth doesn't operate on that clock. Earth thinks in millennia. In slow, patient spans of time where change is measured not by headlines, but by layers of rock, shifting oceans, and gradual chemical balance. That difference in perspective is easy to forget. To us, a slow adjustment feels insignificant, a fraction of a degree, a few millimeters of movement, a subtle change spread across years. But to the planet, those same changes can be critical, because Earth doesn't experience time the way we do. 100 years is a moment, 1,000 years is a phase, 10,000 years is a single breath in a much longer process. What feels stable to us can be deeply unstable to the system beneath us. Humans tend to measure success in growth, more energy, more production, more extraction, more expansion. Growth is visible. It feels like progress, but Earth doesn't measure success that way. Earth measures survival in balance, temperature balance, pressure balance, chemical balance, energy balance. When those systems stay within certain ranges, life thrives. When they drift too far, the system adjusts, not because it wants to, but because it must. And here's what humans often misunderstand. When balance begins to fail, systems don't shout. They don't send warnings written in clear language. They don't stop everything at once. They correct quietly. They shift energy. They redistribute pressure. They change flows that once felt permanent. By the time the change becomes obvious to us, the correction has often been underway for a long time. That's why this moment matters, not because something sudden is happening, but because something gradual may already be in motion. The planet doesn't need to announce adjustments. It has time. We don't always. Understanding Earth's timeline doesn't mean rejecting progress. It means respecting limits. It means recognizing that long-term survival depends less on how fast we grow, and more on how well we stay in balance with the systems that quietly sustain everything we depend on. Not what is happening, but what it leads to. Is this response temporary? A short-term adjustment that stabilizes the system before it returns to a familiar state? Or is this the beginning of something longer, a deeper adjustment phase that unfolds over decades, or even centuries? No one knows. And that uncertainty isn't a failure of science, it's an honest boundary, because we've never stressed the planet like this before. Not this quickly, not this continuously, not this globally. In the past, Earth faced sudden shocks, asteroids, eruptions, ice ages. Those were extreme but brief in geological terms. What's different now is duration, pressure applied everywhere, all at once, heat accumulating faster than natural recovery cycles, systems pushed without time to reset. There is no historical record for that, no past event that perfectly matches the conditions we've created. So scientists can't simply look backward for answers, they can only observe, measure, compare, wait. That's why this moment matters, because we're not watching an ending. There is no final chapter being written. What we're witnessing is a reaction, a system responding to sustained conditions in real time. And reactions can take many forms. Some stabilize quickly, others reshape the system permanently. Which path this one takes depends on variables that are still unfolding. That uncertainty doesn't demand fear, it demands attention. It asks us to stay curious instead of dismissive. To recognize that when a system as large as Earth begins to adjust, the most important question isn't when it will stop, but whether we understand what it's responding to. This is not a disaster alert. It never was. It's a reminder, a quiet one, the kind that doesn't interrupt your day or demand immediate action. But lingers. Earth doesn't need to destroy us to protect itself. It never has. Throughout its long history, the planet hasn't survived by wiping everything out. It has survived by rebalancing. When temperatures drifted too far, they slowly corrected. When pressure built up, it redistributed. When systems strained, they adjusted. Life changed, environments shifted, but the system endured. That's the part we often forget. Earth doesn't operate on emotion or intention. It doesn't act out of anger or revenge. It responds, quietly, patiently, according to laws far older than us. And those responses don't need to be dramatic to be powerful. Sometimes they look like subtle shifts that unfold over years. Sometimes they feel uncomfortable, not catastrophic. Sometimes they go unnoticed until we look back and realize how different things have become. Rebalancing doesn't mean destruction, it means change, and change can be gentle or it can be challenging. That difference depends on timing. It depends on awareness. It depends on whether adjustments happen early or after stress has been allowed to build for too long. This moment isn't about panic. It's about perspective. Understanding that we are part of a much larger system, one that has limits, thresholds, and quiet ways of responding when balance begins to slip. The planet doesn't issue warnings in human language. It speaks through patterns, through shifts, through signals that don't shout but persist. And those signals are easy to miss when we're focused only on the surface. So here's the question worth sitting with, not just as scientists, not just as policymakers, but as people who live here. If a planet can respond silently to stress, are we listening carefully enough to what's happening beneath our feet? Or are we waiting for something louder before we pay attention? Because by the time systems speak loudly,